This is SpaceTime, Series 24, Episode 132. Coming up on SpaceTime, a massive pile of new gravitational wave detections. India says its latest nuclear missile test is meant as a signal to China. And the growing popularity of remote-controlled telescopes among citizen scientists. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have announced another 35 new gravitational wave detections. The new discoveries bring the total number of observations to 90, including further confirmation of rare intermediate mass black holes. Gravitational waves were first predicted by Albert Einstein. He theorized that the movement of astronomical objects could cause waves of space-time curvature to be sent rippling through the universe, like waves caused by dropping a stone into a still pond. Like most of his work, Einstein's predictions were proven correct when in 2015 a gravitational wave signal was detected for the first time by LIGO, the Laser Interferometer Gravitational Wave Observatory. LIGO comprises two identical facilities, one in Livingston, Louisiana, the other in Hanford, Washington State. Each LIGO observatory fires lasers into a beam splitter, which shoots the beams along two perpendicular 4-kilometre-long tubes equipped with a mirrored test mass at the far end. The reflected laser lights then sent back to the detector, where eventually they should, theoretically at least, recombine. But as a gravitational wave, generated by something like a moving mass or merging black holes, passes through the cosmos, it causes the very fabric of space-time to stretch and compress ever so slightly, by just a fraction of the diameter of a proton. And when a gravitational wave passes through the LIGO detector, local space-time, including the two beamlines and the test masses, are stretched and compressed ever so slightly, but enough to leave them out of phase. The signature of a gravitational wave event. Using multiple gravitational wave detectors allows scientists to determine the direction of the wave source. So a third detector called Virgo has been built near Pisa in northern Italy to further improve detection. Now, a key feature of this particular run of detections was the addition of two additional gravitational wave observatories, one in Japan and another in Germany. The 35 new discoveries were all observed during the second half of the third joint observing run, which ended in late March last year. All the newly detected signals come from merging black holes and neutron stars. And the new data includes some interesting surprises, such as an unusual neutron star black hole merger, a massive black hole merger, and binary black holes, revealing information about their spins. While gravitational waves from a black hole consuming a neutron star have already been observed, this new data contains another such event with some stunning conclusions. GW 1912-19-163120 is a merger signal of a black hole some 32 times the mass of the Sun. Nothing unusual there. But what makes it so spectacular is that it's consuming a neutron star just 1.17 solar masses. Now, if correct, that would be the least massive neutron star ever observed. Remember, a star has to have at least 1.44 solar masses in order to break electron degeneracy and collapse down to form a neutron star in the first place. So what's going on here then? Meanwhile, another new observation, GW 200210-092254, shows a black hole merger with either a very low mass black hole or a very high mass neutron star. The majority of the new discoveries are binary black hole mergers, including some very massive stellar mass black holes, which appear to have merged to form rare intermediate mass black holes, proving at least one explanation for how these are made. Other events have revealed more details about the spins of merging black holes. That's a key property of these mysterious and little understood objects. The authors also look for the implications the findings have on science's understanding of the underlying population of black holes and neutron stars and the history of the expansion of the universe. The detectors are currently being upgraded for the next observing run, which is expected to begin late next year. This is SpaceTime. Still to come, India has carried out a test of its nuclear-capable Agni-5 long-range ballistic missile, claiming it's meant to be a signal to China. And we look at the growing popularity of remote-controlled telescopes. All that and more still to come on SpaceTime. India has carried out a test of its nuclear-capable Agni-5 long-range ballistic missile. The nation's defense ministry is describing the test as a stern signal to China, which has been engaged in a series of deadly skirmishes with Indian troops along the disputed Himalayan border. 20 Indian soldiers were killed by China's People's Liberation Army in one attack in June last year. Beijing's also boasted about deploying a microwave heat ray weapon along its border with India, literally cooking Indian troops alive. The 17-metre-tall three-stage solid-fueled Agni-5 has a range of between 5 and 8,000 kilometres. The successful test of the rocket was conducted over the Bay of Bengal. India's deepened its defence cooperation with Western countries in recent years, including the new Quad Alliance with Australia, the United States and Japan. However, New Delhi is also a major buyer of Russian military hardware and has ordered Moscow's new S-400 missile defence system despite the threat of US sanctions over the $5.4 billion deal. This is SpaceTime. Still to come, we look at the growing popularity among citizen scientists for remote-controlled telescopes, not in your backyard, but in one on the other side of the planet. And later in the Science Report, a new study warns that global warming is causing extreme ice melting events in Greenland. All that and more still to come on SpaceTime. A new issue of Australian Sky and Telescope magazines hit the newsstands, and among the stories this month is a feature on the growing popularity of remote-controlled telescopes among citizen scientists. Now, these are not telescopes set up in your own backyard, but ones you have set up on the other side of the planet. Joining us now with all the details is the magazine's editor, Jonathan Nally.
What you can do these days, instead of having a telescope in your backyard, so maybe you might live in a big city where there's a lot of light pollution or something, or maybe you live in a part of the world where you can see some things in the night sky, but you really want to see stuff in the sky that's visible from another hemisphere. So if you live in North America, but you really fancy seeing what's in the southern sky, or vice versa, then you can set up a remote observatory system, or you can use a remote observatory system. Now, there are ones out there that are already set up, they've been going for years, and you can rent time on these telescopes. Companies have set up whole fleets of telescopes in certain locations, and you can get on the internet and send commands to these telescopes to say, take a picture of this or take a picture of that, and bingo, it just happens, right, without you having to buy the telescope. So you can do that if you want. And that's
Is that like
really
Swoop?
well. Yeah, that's right, yes. There are things like that. There are quite a number of them, and they're situated all around the world, and they've got some really big, nice telescopes that you can use with fancy cameras and things. And I get a lot of pictures sent to me by people using these telescope systems, and they're just spectacular because the equipment is really good. You know, you're talking about $30,000, $40,000, $50,000 telescope systems that most people just can't afford to buy, but you can afford to rent it for an hour or something. It's not that expensive. But there's an alternative even to that these days, and that is if you do have a backyard telescope, and you find that maybe the light pollution's got too bad or something, or you want to see a different part of the sky, you can actually pack up your telescope system with its cameras and its computers and everything like that and ship it off to this place in Chile that they've set up in the Atacama Desert, which is very high, very dry, and almost never has clouds and basically never rains. So it's the most amazing astronomy environment. And they will unpack your telescope and everything and set it up there, your telescope. They'll set it up there on a concrete block, and then you just remote control it from home. It's really quite amazing. And lots of people are doing this now, and it's not as hard as you think. If you've got your telescope already set up working at home, and it's one of these computerized ones that you can sit inside in comfort and send commands to it down a cable or Wi-Fi or something, then you can actually pack the whole thing up, ship it off to Chile, set it up there, and just take pictures. Might be daytime where you are, but it's nighttime there, so it's taking pictures, and after dinner, you can go and download all the pictures that it's taken and say, wow, look, that's my telescope, thousands and thousands of kilometres away, taking pictures of things that I can't see from here. So it's a really interesting option that a lot of people are taking up. And we go right into it in detail in the magazine, and we basically one person's experience of how they did it and how they found it to be far easier than they thought it was going to be.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. And time now for another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that global warming has caused extreme ice melting events in Greenland to become more frequent and more intense over the past 40 years, raising sea levels and flooding risk worldwide. The study by the European Space Agency shows that over the past decade alone, some 3.5 trillion tons of ice has melted from the surface of Greenland and flowed down into the ocean. That's enough melted ice to cover the entire United Kingdom with around 15 metres of meltwater. The new study is the first to use satellite data to detect this ice sheet runoff from space. The findings, reported in the journal Nature Communications, used measurements from ESA's Cryosat-2 satellite to reveal that Greenland's meltwater runoff has risen by 21% over the past 4 decades and has become some 60% more erratic from one summer to the next. Scientists have found that people who are genetically predisposed to a higher risk of psychiatric disorders like schizophrenia, bipolar conditions, or anorexia nervosa are also more likely to live in or move to urban areas. The study, reported in the Journal of the American Medical Association, also found that people with a genetic risk of autism spectrum disorder were also more likely to live in or move to high-density urban areas. Which is ironic considering people with autism are often blasé about the company of others. The authors say this new study suggests that genes may influence people's choice of living environment and that liability to these disorders predisposes people to inhabit more urban environments. The struggle of cutting takeaway food with a flimsy wooden or plastic disposable knife could be a thing of the past, with scientists creating a knife out of wood that could cut a medium well-done steak just as well as its stainless steel rivals. Researchers have developed a process for removing some of the weaker components in wood while at the same time keeping the stronger elements intact. A report in the journal Matter says the research can generate more sustainable material for sharper objects like knives. The authors believe this material could be used for more environmentally friendly reusable knives, rust-proof nails, and even more durable hardwood flooring. Therapeutic touch is one of those pseudoscientific contracts claiming to cure everything from cancer to crabs. Of course, its real purpose is to separate gullible people from their money. As Tim Mendham from Australian Skeptics explains, it only took a 9-year-old girl to totally discredit the practitioners or healers who were pushing this woo to the weak-minded.
It's a lovely story. It's actually from the mid-90s, and it shows that anyone can be a skeptic and anyone can be a scientific skeptic. This involves a, quote, medical treatment, unquote, called therapeutic touch. Now, therapeutic touch does not involve touch. So why it's called that, I don't know. What it is basically a practitioner or a healer moves their hands over your body. They don't touch the body. They just move it a few inches above, etc. And they can feel bad energies and then dismiss them. And you don't want to be in the area when they dismiss them because you might be covered in all the bad energies. But anyway, they can do this, perform therapeutic practices without touching. So this is a 9-year-old girl in America who set up this test and said, pretty straightforward way of doing a test. Okay, you're a therapeutic touch practitioner. Come here, stick your arms arms through these holes in a bit of cardboard. She set up a bit of cardboard. Stick your arms through at a slight distance from each other and put this towel over your head and over your arms, and then I will hold my hand over one of your hands, and you can tell me which hand my hand is over. Pretty straightforward. You got a 50-50 chance, really, well, just by guessing. And so she got a lot of therapeutic touch practitioners to do this, mainly because it was actually part of a science fair. She was in fourth year of school. This was her project. She was 9 years old, and she got all up about 21 people to do it. 14 of them were given 10 chances. So they should have got a 5 out of 10. And 7 of them were given 20 chances, and they should have got by chance 10 out of 20. So they should be 50% just by tossing a coin. They actually ended up getting 44% correct. So in other words, they were below chance. And of course, as soon as they fail, and this happens with that, we know in our skeptics challenges, as soon as people fail, they'll find an excuse for why they failed. Certainly not the fact that they don't have a skill. Oh, no, they don't doubt that. What they will find is that the circumstances were wrong, even though they often agree beforehand that the circumstances are fine, but they've said things in this particular case, oh, it was too cold, or the air conditioning was blowing the force field away. not much of a force field. I wouldn't use that to fight off missiles in space if the air conditioning can blow it away. Stupid excuses. They're obviously desperate to try and find some reason why they failed that wouldn't involve them not having a particular skill or that this skill was shonky. But basically, therapeutic touch is shonky. It's the sort of thing that this was a nice test. She actually got it published in the Journal of the American Medical Association when she was 11. That made her the youngest person to be published in a peer-reviewed medical journal. So good on her. A simple test, well performed, straightforward, clear results. Classic skepticism.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.